Our project located in Abu Dhabi. The site is in Al Nahyan camp that is surrounded by multiple services, park, hospital, restaurant, mosque, and is accessible to the public transportation through Dilma Street within a walkable distance of 500 meters. The site is accessible by car through the main road and minor road and pedestrian routes. Here we show the sun path and the prevailing wind come from northwest side. Here we show the sun radiation through the whole year. For the temperature, the hottest month is July, where the temperature reaches 47. The coldest month is February and January. The climate in Abu Dhabi is mainly hot and humid, but still 9.6% of the year is comfortable. The module of the house has been generated from a very basic module 60 by 60 cm, and by combining these modules we got the form and size of the house modular envelope. We determine the optimal height of the envelope using the same source module. So this is the final size for box envelope, which is 5 by 15.8 by 4.5 meter high. As we got a modular boxes to be arranged within the given plot. The final architectural plans for the basic mode. The modular blocks will be shaped using a precast modular walls.
For the improved envelope, a concrete sandwich panel with a 10 cm phenolic insulation will improve the transmittance value to 0.19 watt meter square Kelvin as per Istidama calculator. And a green roof of 20 cm soil for vegetation has improved the transmittance value to 0.185 watt per square meter Kelvin. Doubly glazed windows with thermally braked aluminum frames will be applied to the envelope. The passive design strategies across ventilation is applicable, and the wind tower with operable windows allow to get the benefit of stack effect. Determine the optimal orientation. After we relocated the building in 8 different orientations, we selected orientation number 5, not only because it has the lower energy consumption, but also it has a self-shaded elevation toward the southwest, and because of its alignment to the adjacent road. Determine the study case scenarios. We selected for the city of Abu Dhabi 30 of January and 30 of July the dates for maximum and minimum temperature, 30 of April for the average scenario, and each specified date will be studied in 3 different times: 9 morning, 12 midday, and 4 afternoon. So in total 9 different scenarios to be analyzed. Determine solar altitude and azimuth. After getting the data of the sun altitude and azimuth from the IAS, we highlighted the related angles and apply it for each scenario as per its correct position. Determine the optimal orientation. After we relocated the house in 8 different orientations and calculating the predicted energy consumption for each direction, we highlighted 2 preferable orientations because of their alignments to the road and they have the lowest energy consumption. Then we selected orientation number 5 not only because it has the lower energy consumption, but also it has a self-shaded elevation toward the southwest instead of the exposed one for orientation number 2. Kinetic system concept. The kinetic system designed to be an automated system with variable modes, which can be controlled, programmed, and optimized through smart home system controller. Mode number 1, the sleeping mode, which is totally closed. Mode number 2, east-west mode, can stop the solar radiation but still allowing the view and diffuse light to enter the house. Mode number 3, canopy mode, which allow for full view and diffuse light to enter the house. Applying the kinetic mode. In order to apply the correct kinetic mode in the correct location and time, we use 3 different diagrams, A, B, and C, which represent the sun locations for 9 a.m., 12 midday, and 4 p.m. And we gave a symbol for each kinetic mode to apply the suitable mode in its suitable location. After this arrangement done, we got 3 different models to be tested in its related scenario. The motion of the kinetic system and its modes. First, sleeping mode. It's blocking the light from going inside, also blocking the artificial light at the night from escaping to outside, so reducing the light pollution, and it's used for sleeping time and during the day when there is no occupancy in the space. Right-left eye mode. It's allow one side of the frames to face the solar radiation while the other side will remain protected, so to open its eye by rotated louvers to allow view for occupants and more daylight to enter the space. The canopy mode. It's suitable when the solar altitude is high or in case of the absence of the direct sun radiation to allow full view and maximize the daylight for the space. Kinetic system analysis. Kinetic case comparing to the base case in terms of sun cast. Kinetic case comparing with the base case in terms of temperature and solar gain. The kinetic case on January show an average reduction of 7.5 Celsius degree and the temperature achieved in all January scenarios was within the comfort range, so no air conditioning is required. For the 30th of April, an average reduction of 6 degrees Celsius, but still the air conditioning is required, as the temperature still above the comfort range. And on July, the average reduction was 5.5 degrees Celsius, and the air conditioning still required. In terms of energy consumption, on 30th of January, an average reduction of 4.42 kilowatt in space cooling energy, and a 3.14 kilowatt on 30th of April, and a 2.75 kilowatt on 30th of July. Term of daylight illuminance. This comparison on 30th of April at 9 o'clock showing that the average lux levels in the ground floor has been reduced from 877 lux to 243 lux with daylight factor of 1.9, which consider within the comfortable range for casual seeing and easy visual tasks. And in the first floor, the average lux amount reduced from 1000 lux to 240 lux. And in terms of radiance, The comparison here for 30 of April in the Majlis block show a reduction in lux amount at 9 am from 950 lux for the base case to a 350 lux in kinetic case, which consider optimum for the space function, and at 12 midday a 200 lux with a DF of 2%, but at 4 pm a 150 lux, which is normal for casual seeing, but artificial lighting may be required for some perception of details.
Here we show the air temperature, velocity, pressure differences between base case and kinetic case.
The use of renewable energy. The project has a 17 photovoltaic panel in the roof, with total energy production of 3.4 kilowatts. Used for the project average cooling energy consumption. But in winter the cooling energy consumption is zero, so the solar power could be used for artificial lighting. In spring and autumn, the solar energy will stand for 72% of cooling energy consumption, and for summer, it will stand for 42% of the cooling energy consumption. Base case against SDBE peer rating system. One of the SDBE key initiatives is the peer rating system, which aim to address the sustainability of a given development. The peer rating system has 5 levels from peer 1 to 5, as per the points the project can obtain from 8 different categories. In this particular project, the objective was to achieve peer 2 for the base case design. The peer rating of the kinetic case. The objective is to achieve a peer 4 for the kinetic design case, by further improvements in different categories.